So for this example, given that water is running out from a conical funnel at the rate of 1 cm cube per second. So your water is coming out. And we read for this 1 cm cube per second. Cm cube is a unit for volume. Meanwhile, second is a unit for time. So this is the rate of changing of volume. So our first step, identify the information, the variable, the constant, and the shape. And the shape we can see here is conical funnel. So our variable here, our changing variable here is volume and time. So when you're running out, means your water inside, the volume for this water, you are getting decreasing, getting lesser and lesser. So our rate of change will be in negative. So here we have negative 1 cm cube per second. The first information come out from the first sentence and we identify the shape. If the radius of the base of the funnel is 4 cm and the height is 8 cm, so we're talking about the funnel, the container here, the funnel here. So this funnel, this container 8 cm and radius is 4 cm. So for this 4 cm and 8 cm funnel, it's a constant variable. As your water coming up, your container will not getting smaller. Your container will maintain as usual. So 4 and 8, this one is your constant variable, which is your cone shape, your container variable for the radius and the height. Find the rate of the water level. So your changing variable here is your water level, which is H. At the rate of your water level is dropping when it is 2 cm from the top. So 2 cm from the top means you're changing at H. So total height is 8. When you're dropping until 2, you want to see what's the rate here, what's the changing here. So when you're dropping 2 means your height here is remaining 6. So we want to find the rate of change at H equals to 6. Then the question asks the rate at which water level dropping. So your question is asking dH dt. So the first step, identify the information and shape. So second step. So look back our first step. So remember, what is your variable? Your variable is not happen at your conical funnel. Your variable is happen on your water here. As your water running out here, so your water volume is variable. So this is water volume. And when you're dropping out your water height. So this H is referring your water height is your variable, changing time from time to time. At the same time, your R is your water radius. Also one of the variable when your water coming out. So your radius of the conical funnel and your height of this conical funnel, they are constant. So identify what is your variable and your constant. So continue step 2. We have to determine what is our chain rule needed here. So you can see we want to find the rate of change of your height, water height. So dH dt equals to dH. So what's the variable that we can link here? Look at our information. So the height of the water here can link with the volume of the water. So our chain rule can be formed dH over dV times dV over dt. So that will be our step 2. Then we go to step 3. we want to consider the equation needed here. As we can see here, dvdt is given from the questions. So what we need to figure out is dh dv, means we need to figure out the equation needed, of course, volume in terms of h. So volume in terms of h. But as we recall back our volume of the cone, why we taking volume of the cone? Because the water is follow the container shape. As the container shape is conical, means our water also in conical shape. Therefore, the volume changing here is using conical formula. So conical formula will be 1 over 3 pi r squared. So notice that our variable here, we have volume, we have radius, we have height. All these volume of the water, height of the water, radius of the water, all these are variable. So in step number 3, the equation once here is volume in terms of h only. So our volume is in terms of two variables. So we want to form the formula into single variable. So as we have two variables happen together, we can't differentiate this. So we have to use another related equation to form our formula in single variable. So that is what we mean by the step number 3, finding the formula in the single variable. So we need to combine the equation. So look at our equations here. We want V in terms of H. So means this radius we need to find out what is the formula related radius with H so that it can change in terms of H. So when we having cone here, we can use the similarity of triangle. So what is the similarity of the triangle? Look at the cone here. The container here, or the conical funnel here. So you can look at the right triangle. You can observe here we have a right triangle here. So for the container, or for the conical funnel, so this right triangle is constant with the radius 4 and the height of 8. So this is constant. And when we having water inside here, actually our water also follow this conical funnel. So this water also having triangle shape, having a similar triangle here. So why we call it similar triangle? Because you can see the water triangle angle are same with the container angle. So for this triangle and this triangle, they are similar. It have same 90 degree, and then it have one vertex, they are same degree. So compare this. So this is our water triangle here, which is radius and height. So by the similarity of the triangle, we can do this ratio. So how to do this ratio? Where R is ratio to H, it will be similar as 4 ratio to 8. So R is radius, so radius ratio to height, so 4 ratio to 8. So our R will be in terms of 4 over 8 H. So R will be 1 over 2 H. So now we manage to relate our variable R in terms of H. So therefore, R is equal to 1 over 2H. Then we substitute into our formula so that we can get our formula into a single variable. When we substitute here, so V will be 1 over 3 pi R square H. As we expand, this is 1 over 4 H square. Square this, so 1 over 4 times 1 over 3, 1 over 12 pi h squared times h, we get h cubed. So this is the formula that we want. V in terms of h. So formula V in terms of h, so that we can differentiate V respect to h, then we inverse it to get dh dv. So step 3, finding equation in single variable. So V in terms of h, then we can start differentiate this V respect to h, power turun depan 1/4 power tolak 1 h square. So if I write it properly, numerator will be pi h square, denominator will be 4. What we need is dh dv, so we inverse it. 4 become numerator, then pi h square become denominator. So finish for this part. We managed to find this chain rule dh dv. So lastly, step number 4, we're going to substitute all the information back to our chain rule that we form here, as dv dt is equals to -1 and dh dv is 4/pi h squared that we found. And what is the h? So h is the value that we want to find the rate of change. So they want to find the rate of change when the water level drop 2 cm from the top. So the height is equals to h. So this is the value that we need to substitute into our chain rule. dh dt equals to dh dv times dv dt, and the h is equals to 6. So press the calculator, we can get this one. Or I can simplify directly. I can get this one 9 pi, -9 pi cm second. So why cm? Because look at the beginning of the questions. Everything, the length here, the volume here defined in cm. So the height also in cm. So why the time is second? Because in the beginning our time using here is in second. So I just simplify off here. So if you don't want to let your answer in fraction, we can press it into decimal. Which will be equals to -0.03537. So either one to be. Then you can see our rate of change here is negative, means we explain in sentence they are decreasing. The rate of decrease of this height is 1/9. So when I already said decrease, negative no longer to be written. So the negative already represent in word, which is decrease.